Okay, recording start. Okay, so today what we are doing is on your tutorial 5. Okay, it's a bit tough. Right? Okay. Okay, what do I do? Auto rotate? Yes. Does it work? Hey, hello. It doesn't work? Now let's try this again. Ask me before switching. Yes. Okay, and I'm gonna kill my laptop this way eventually, I think. Do you want to switch to tablet mode? Yeah. And it doesn't switch. Okay, what the hell is wrong with it? Can anybody explain to me? Okay, anyway. Now, yeah, I don't know what is wrong with it. Okay. Remember my response? Don't ask again, obviously. Yes. Anyway, let me try again. Okay. It seems to work. No. One. Okay. Tablet in. Okay. Let's see. Go to settings. Then which one? Settings. Any idea? System, display. Okay. And any idea where next? Strangely, it works the last round, so I'm not sure why it doesn't work this round. Huh? Rotate. Where is it? Yeah. Turn rotation on or off.
Rotation clockwise in gray.
Rotation clockwise in gray. Flip. Portrait. Nope. This is even worse. Oops. Revert. Okay, now I'm in the wrong orientation. I can't even move my mouse properly. Anyway, yeah, it's in gray. So what the hell has just happened? Anyway, doesn't matter. So we'll see what we can do with this laptop. So I'm going to have a hard time writing it. So anyway, let's get to it. Let's not waste time. Okay. You look cute. Okay, so what we are going to do is to do some revision. So the first thing is we want to go through the steps of hypothesis testing, which we have gone through already. So the steps in hypothesis testing, can you remember what are the steps? Okay, we have gone through on Tuesday. Just briefly give me the steps. What is the first thing? Step number 1.
Derive the null hypothesis and alternate hypothesis.
So you have to, derive the null hypothesis and alternate hypothesis. Okay. With this, you also need to define what is, you also have to derive or give the alpha value. And you also need to decide whether is it a one-tail or two-tail test. Okay. So after you have the hypothesis, so null hypothesis, alternate hypothesis, alpha value, one-tail or two-tail test, these 4 pieces of information should be there. Okay, and each one can carry marks. Okay, then after that, what do? You collect your data. Okay. So for most of the time, this is the experimental part. But as far as BDA is concerned, the data is given most of the time. Okay. So the third, after you have a data, what do? Anyone?
Test the hypothesis. Test against the hypothesis.
Okay, so you test the hypothesis. In other words, you decide on the test, the statistical test. Okay, after that, you calculate the statistic based on the test. Right, calculate statistics based on the test. Now, this is crucial. Okay, if you don't calculate statistics based on a test, then you're going to get it wrong. Okay. Now, after you calculate the statistics based on a test, what is the next step? Okay, you decide. So your decision. The decision is to, there's only two decisions. One is to, that you fail to reject null hypothesis. The other one is you reject null hypothesis. Okay, so what is the criteria? So let me just erase this part first. What is the criteria to fail to reject or reject? When you fail to reject your null hypothesis, essentially your statistic, okay, the absolute of the statistics is greater than the critical value. So once, basically, it also means that once you decide your statistical test, using the alpha, you also have to derive what is the critical value here. Okay. So we say that this is for your paper calculation. Okay. For your computational calculation, you use something different. For a computational calculation, what you do is, hey, where's my rate? This is my rate, correct. For a computational calculation, it will be the p-value is larger than the alpha value. Okay. So to reject the null hypothesis will be the opposite. The statistic that you calculated in step number 3 is smaller than the critical value. In computational terms, will be the p-value is larger than the alpha value. Okay, so either one. Okay, so this is the paper version. This is the computer version. Once you have that, you start with, go to step 5. Okay, you do your interpretation. Interpret your results. So interpret your results is basically answering to the question. It is almost like when you do in primary school your problem sums, writing the last sentence, what does it really mean? Okay. So this is critical. Now, every statistical test, every hypothesis testing follows this scheme. The only thing that will be different is here. The only thing that will be different is what statistical test you use. And because of that, you calculate the statistic differently. That is the only difference for all statistical tests. And there are hundreds and hundreds of statistical tests out there. Okay. In certain cases, you may even create your own statistical test. It's actually possible using this scheme. All right. Very, very important will be do not mess up the decision.
Just sorry.
Yeah.
For the p-value, right, to fail to reject, is it p-value bigger than alpha or smaller?
fail to reject P C statistic more P value larger than alpha. Yep.
Okay, thank you.
This P value is, oops. P value is P value is larger than alpha. This is smaller than alpha. Okay. Then I will quickly sort this up. Okay, the statistic is actually fail to reject. Yeah, statistic will be smaller. This will be larger. Swap it the other way around. Okay, so this is actually very important. Okay, make sure you do not accept or reject null hypothesis wrongly. Okay. So again, once you fail to reject null hypothesis, the conclusion is you accept null hypothesis. If you reject null hypothesis, the conclusion is you accept the alternate hypothesis. Okay, the next part that I want to stress here is also based on your notes. When you accept null hypothesis, it doesn't mean that null hypothesis must be true. Okay. One, it does not mean null hypothesis must be true. What it really means is there is insufficient evidence to say null hypothesis is false. Okay. There's just insufficient evidence. Because remember, you only reject your null hypothesis when, in general, the null hypothesis has less than 5% chance of being correct. Only 5% chance. It's like your passing mark is 5% out of 100. Okay, so these are very important concepts. So this is what it means by what happened when you fail to reject null hypothesis. It doesn't mean that null hypothesis must be true. It simply means that your evidence does not show null hypothesis is false. Okay. It is almost like when a person, a suspect, get trial for a murder case. Okay. If he is acquitted, that means not guilty. It doesn't mean that he is 100% not guilty. It simply means that there is insufficient evidence to say that he is guilty. Right? I'm sure you heard of cases whereby after a few years, that person get retried again and found to be the criminal. Because at a point in time, there's insufficient evidence yet. Okay? So this is a very important concept that you have to follow. Okay? Any problem with this? No, you're innocent until proven guilty, not the other way around. So if you cannot prove the person guilty, automatically the person is innocent. If you have insufficient evidence to prove that person guilty, then the person is still innocent. Even though your gut feeling or whatever tells you that the person is likely to be guilty, but you cannot find enough evidence yet, then you suck thumb. Nothing much you can do for now. Okay? If you want to redress, find more evidence. So how do we find more evidence in statistics? Collect more data. Okay? Collect more data points. Okay? So this is a very important concept. Now, how is your statistics test different from the probability of X which we done in last week? Okay. So, here, how is statistical says different from, let's say, what you did last week, the probability that x is larger than a value. What you are looking at is, this is a question. What is the probability that the average value from your data is different? By different, I mean a two-tailed test. This becomes a two-tailed test. From an expected average value. We are looking at average values versus average value here. We are not looking at value versus value. Okay. Now, when you did for your last week, you'll find that you keep on using the difference divided by the standard deviation. The denominator is standard deviation, correct? But when you do this is your statistical test, it is actually the difference in the two averages divided by standard error, not standard deviation. Okay, so this concept is kind of a bit fuzzy in the lecture notes. Okay, so what do I mean here? Okay, for example, let me just use a different color. Let's say for this, I'm asking things like, let's say the mean is, let's say the mean height is 170 cm. The standard deviation of the height is 5 cm. Okay, I'm asking, what is the probability of a student, let's say taller than 175 cm? This is talking about one student. Okay. While the other one, your hypothesis testing, same thing, the mean height can be 170 cm. Okay, the standard deviation can be 5 cm. But I'm asking the question, what is the probability that the average height of, let's say, 10 students that is taller than 175 cm. So I'm looking at the average of 10 students here. Okay, and because of that, you use standard error instead of standard deviation. So standard error in this case will be, you keep on seeing this, your standard deviation divided by square root of n. Okay, for all your calculations. Okay, let's see. Okay, let me just go back to my panel. Picture 1, what else do I have to cover? Okay, so do you know, can you from the question know the difference between asking you to find the probability of a student and asking you to find the average probability of 10 students? It's just a few words difference, but don't mess it up. Okay, Very important, don't mess it up in your term test. I keep stressing it, so learn how to take some hints. Okay, so now, did I save this? So, what is the difference? Then my next question is, what is the difference between your normal distribution and your t-distribution? Anybody? Why do we have normal distribution than your t-distribution? Of course, you can say that normal distribution is to use for z-test. Your t-distribution is to use for t-test. But you find that the equation for z-score calculation and t-score calculation is identical. So why is there two distributions that you can use? And it will tend to give you different results. Okay, let's just see these two scenarios. So you have case 1. Okay. Case 1, for example, you want to say that, again, our others ice cream, you want to say that the average weight of your others ice cream is 60 grams. Okay, that is, okay, in fact, I should use this. The average weight is 60 grams. Okay. Case 2, you also want to find the same thing. The average weight for your cup of other ice cream is 60 grams per cup. Okay. Then from there, you do your hypothesis. The null hypothesis is that the average weight is equal to 60 grams per cup. Alternate hypothesis is weight not equals to 60 grams per cup. Okay, same thing here. Case 2 also the same. Okay, and then you decide all the alpha value, everything will be the same. It doesn't matter. Okay, but case 1, I have one group of you. Let's say you are very energetic, you go and hunt down by 100 cups. Okay, and your result comes out to be the average weight that you calculate, it is 59.5 grams. Your standard deviation is, let's say, 0.5 grams. And after this, I never actually do the calculation, so I'm not sure whether it's right. The end result is you decide you accept the null hypothesis, assuming. Okay. But case 2, another group of you decide, okay, why do I want to buy 100 cups for? Anyway, after I buy 100 cups and I clean out 100 cups, weigh them, half of the time I go eat, right? And other ice cream is really quite expensive. You buy 100 cups of other ice cream, how much it cost you? $400. So you decide that, why not you just be a bit lazier, you just go and buy 10 cups. So that is the only difference. One is 10 cups, one is 100 cups. Assuming that you still get the average weight, 59.5 grams, the standard deviation is still 0.5 grams. So the conclusion is you still accept the null hypothesis at the end. which group of students will you trust the result better? Case 1, right? Okay. Simple. Case 1, you trust this better. Why? Why you trust case 1 better? Intuitively, because larger sample size, right? Okay. But is case 2 doing okay? Now, can I be even, what is the smallest number? What is the smallest n can I calculate standard deviation? Can I even have a case 3 that does the same thing, except n, they use the minimum, 2 cups. And the result is also the same. Average weight is 59.5 grams. Standard deviation is 0.5 grams. Still, except null hypothesis. Now, then my question is, which of these 3 cases, which one will you throw out the window? Right? This case 3, you throw out of the window. Because why? The sample size is just too small. Right? You only have 2 cups. Okay. But if you use all of them on Z test, all 3 cases are the same. So there is no way of putting the sample size, of accounting for the sample size into the equation. In other words, the smaller sample size, the more buffer you have to give it. Correct? The more sample size, the smaller the sample size, the more buffer you have to give it, or the more unsure you are. Okay, so this concept is actually very important. Okay. The smaller the sample size, the more unsure you are with the results. Which inversely means that as your sample size grows larger and larger, you become more certain of the results. Right? How do you beat 100, sample size of 100? Do sample size of 120, and more and more and more, until hopefully eventually, theoretically, you meet the entire population. Then you are 100% sure. Okay. So indirectly, this means that your normal distribution is for infinitely large sample size. But mathematically infinitely large is a bit hard to say. So usually most people say that if sample size is more than 30, Z distribution, normal distribution is quite okay. So T distribution is somewhat your normal distribution okay, but you have some correction for small sample size. Okay, so that is a concept. When the sample size is small, you use T distribution. When sample size is large, you use normal distribution. And we say that sample size small means it is usually less than 30. Okay, and in order to do that, we add another parameter known as degree of freedom. or df. Okay. So let me repeat this whole context again. What I'm trying to say is, when the limit, when n approaches infinity, infinity or large, t distribution approaches normal distribution. Okay. So what is degrees of freedom? What is degrees of freedom here? Based on your lecture notes for t distribution. How do you calculate degrees of freedom?
Is it n minus 1?
Okay, most of the time, yes, correct. In this case, your t distribution degrees of freedom is, yes, n minus 1. Of course, then my next question is, why is n minus 1? Okay, let's go to our dear Mr. Wikipedia and look at what on earth degrees of freedom means. Okay. So this is mathematically the correct definition for degrees of freedom. Is the number of values in the final calculation of a statistic that's free to vary. And you continue reading, these are the correct definition. You have actually hit one of the toughest concepts in statistics so far, degrees of freedom. A lot of students in university doesn't even understand this. The more you read, the more confused you get. Okay, I give you 1 minute to go and read through. The more you read, the more confused you get. What on earth degrees of freedom is. Anybody can understand the second paragraph in the first place? This is a part of statistics whereby you understand every single word, but when the words put together, you have no idea what it means. So, what I want you to do is a simple experiment, and we will test out what degrees of freedom really means. Now, I give you, tell you that 6 numbers, whether is it large or small, positive or negative, gives you add up to 100. Okay, so randomly give you some numbers. Any random number. Can be large, small, minus, positive. I need some numbers. Okay, 21.
-4.
-4. Any more? Quick. 7. Next. What? What? -50. Other one? 76. So what's the last number? It has to add up to 100, you know. So now take out a calculator and calculate. It has to add up 100. Assuming the calculation is right. I'm not going to check that. What's the answer? 50. Exactly. Okay, so 50. Okay. You realize that although I have 6 spaces, 6 data points, but in order to get 100, the moment I put the 5th data point in, the 6th data point is fixed by the equation. That is why degrees of freedom, the points able to move by the equation is, in this case, n minus 1. I have 6 possible holes to put a number, 6 possible spaces. I put the 5th number in, the 6th number is fixed for me by the equation. That is what degrees of freedom really means. After you read through a whole long list of text, I can reverse it and say that the average of the 6 numbers is 100. That makes your life even more difficult. Or the standard of the standard deviation of 6 numbers equals 100. That's even worse. But the concept lies the same. You put the 5th number in, the 6th number is automatically fixed for you. Okay, so in this case, n-1 is the degrees of freedom for T distribution. So let's look at this concept. Is it true that when sample size becomes larger, when degrees of freedom becomes larger, T distribution looks more and more like normal distribution? Correct? That's what I'm trying to say. So let's try this. Okay. Let us use our dearest Excel to do a simulation. So I have from T from -5 all the way to 5. I don't have to do it, just look at me doing it. So the first one I want to look at is degrees of freedom equals to 1 degrees of freedom. That means sample size of 2. Okay. So let me just match it up. And I say that my T distribution is the value here. So I will just lock it up. Okay. Degrees of freedom is 1 and false. So this is my value. This is my distribution curve. Not too bad, not too bad. But what happens when I look at higher degrees of freedom? For example, if I go to degrees of freedom equals to 5. All I need is to just change this to 5. You see, it starts to, the standard deviation closes up. If I have degrees of freedom of 10, it looks high, the peak becomes higher, higher, the edge closes up even more. Okay. Let's say I go to degrees of freedom of 30. Do I have enough space? Yeah, enough space. So you see? And finally, I compare it to what is the degrees of freedom for your normal distribution. By right normal distribution, you will see that the edge closes up even more and it will be bigger, higher peak, right, at that point in time, at this point. Okay, so let's test it. Your normal distribution, okay, mean is 0, standard deviation is 1, and false. See the blue line? That is the normal distribution. So as the sample size increase from 2 to 6 to 10 to 31, it approaches normal distribution. And you can see that the last two, the gold line or the orange line and the normal distribution line, the top blue line, almost overlaps. Almost overlaps. The last two lines almost overlaps, correct? Compared with the rest. This is why when sample size is more than 30, the difference is going to be lesser and lesser. You end up with the 5th decimal point difference, 6th decimal point difference, and so on. That's why when sample size is 30 or more, you can use normal distribution instead. Make your life easier. Okay, so this is the argument. Okay, later I'll post this up. You can post this on the, I might as well just post this on the group. So you can go and play around with it. Okay. Where on earth is this? Normal. Okay, so you can go home and start to play around with it. All right. So this is the real reason. And from then on, what we have is, when do you use z-test? When do you use t-test? Yeah, I know this is a confusion part. Okay. When to use z-test or t-test? Okay. Let us just settle the non-confusing parts first. Okay. Number one, if the one that has no argument is if the sample size is more than 30 and the population variance, also if you know a variance, you know a standard deviation. Population variance or standard deviation is known. Then this one, no argument, you use z-test. Correct? No argument about this. If the sample size is small, less than 30, and the population variance is not known, this also no argument. You use your t-test. So the other two in between arguments is the one that's problematic. Okay. So what happens? So this is no problem. So you have the third condition and the fourth condition. What happens when sample size is more than 30, but population variance is known, is not known? Okay. And if n is less than 30, but the population variance is known. So these are the two subjective parts. Okay. So these are two portion and subjective. So for that, I talked to your subject leader, and the decision is, and my mouse is dead, the decision is we will follow exactly what is given here. So if the population variance is known, or the population standard deviation is known, automatically you go z-test, regardless of sample size. Okay. So in this case, where do I get my... So if population variance is known, this is important. You don't care about sample size anymore. You use z-test. Correct? How about if population variance is not known, but sample size is more than 30? Let's go back. If population is not known, but sample size more than 30, you also use z-test. Okay? So in this case, this is also z-test. So in other words, you only use t-test for one of the four conditions. Okay? All right. Now this is a confusion because in real life, population variance known is the most difficult to get. You never know the population variance. You can actually have sample size is more than 30 possible. But think about in your lab experiment, you're not even going to have sample size more than 30. Correct? How many replicates you do? Duplicates, triplicates? That's only n equals to 3. You're not going to have n equals to 30. Right? That is why we use t-test in real life most of the time. Okay, so that settles. Okay, hold on. So that settles all the problems that we have. Hopefully you're clear about it. Okay, so next, let's go to our tutorial questions now. Okay, let's look at just tutorial question number 3. How do you do that? Okay, tutorial question number 3. A certain bus company claims that the mean waiting time is 5 minutes. Okay, so the mean waiting time, they say that it is 5 minutes. Company. So but the Transport Ministry thinks that the bus company is under-reporting. You only care about under-reporting, not over-reporting. Because under-reporting means that the people waiting for bus is going to complain. The post service, right? So the alternate hypothesis is that the mean waiting time, the Transport Ministry thinks that it is more than 5 minutes. Okay, and because of that, this is a one-tail test. Okay. So the alpha here, if it's not given, it's actually given 0.05. Okay. However, the experiment investigate, you have 100 commuters. Okay, and the reported calculated mean waiting time is 5.5 minutes. The standard deviation is 2.7 minutes. Okay. Do you use z-test or t-test here? Based on the graph. Z-test, correct. So, no problem, you use z-test. Okay. So let's calculate the z-test itself. So z-test, the z-score, it will be the sample mean minus the population mean divided by n. Okay. So in this case, it will be 5.5 minus 5 divided by 2.7 square root of minus square root divided square root of 100. So you do it well, it is about 1.85. Okay. So if you go to the Z table, since you only want the right hand side, the Z table, the shaded area so this is 0. This is Z table. Your area here is 0.05. What is this value on the Z axis? Okay, you do it carefully, read carefully, this is 1.65. Okay, 1.65. Okay. So, do you accept or reject the null hypothesis? Is the z-score in the shaded region or the unshaded region? Anybody? Shaded region, right? Your z-score is actually here. This is 1.85. So then you write, okay, since the z-score is more than the z critical value, because the z critical value is 1.65, okay? So z critical value equals to 1.65 here. you reject null hypothesis, you accept alternate hypothesis. Then what does it mean? Therefore, it is likely that the bus company underreports the average waiting time. All right. You can. Underreports waiting time at 5% significance. You can actually say that. Okay, so we are actually quite. Yes.
Sorry, is this one right tilt or left tilt? It's right tilt, right?
Because you want to be more than 5 minutes, ma. So if you look at the time score, right? So this is average time. Okay, it's 5 minutes. You are interested whether is it more than 5 minutes or less than 5 minutes.
Okay.
Yeah, because remember the question says that the Transport Ministry think that the bus company is under-reporting. So they only care about under-reporting. They don't care about over-reporting.
Okay, thank you.
Okay, so that's question 3. Okay, so let's go through. Anybody done question 4 already? Okay, so quickly, question 4. You've done it. What is your null hypothesis? Okay, so the average pull-up equals to 7. Alternate? Correct. Greater than 7. Okay. But yes, null hypothesis is no difference. That's a default. Okay. So in this case, you use z-test or t-test? Huh? T-test, right? So you use t-test. Okay, I'm just doing an abbreviated version. So your t statistic that you calculate, you get what? 0.327. Okay. Then because the alpha is 0.05, then your t critical is actually 0.05. What do you get? How do you find the critical value? Yeah, correct. 19. Because so degrees of freedom is 19. 1.729. Okay. The main thing is to read the table properly. Okay. So the easy thing is for your term test, please print out your tables, your normal distribution table and your Z distribution table. And at home, you have over the weekend, go and buy 2 rulers if you don't have 2 rulers. The last thing you want is during term test, you get panic and then you have parallax error reading the table. A lot of students have that. They look at the wrong line. Okay. So, do you accept or reject null hypothesis? Yeah, so you fail to reject. In this case, you accept the null hypothesis. Okay. All right. So question 5. Any problem in question 4? Do you get the same answers? Okay. So question 5. What is the null hypothesis here? Okay, telephone company Durian launched its newest smartphone iDurian and claims that battery life is during normal usage is 22.3 hours. A rival company thinks that the battery life is not 22.3 hours and acquire 45 sets to claim it. So after testing, the sample mean is 21.9 hours with a variance of 25 hours squared. Is there sufficient evidence at 10% significance? So what is the null hypothesis? Yeah? Okay, so equals to 22.3 hours. Alternate hypothesis? Okay, that's not equals. Because of this, this is a two-tailed test. Okay. Then for two-tailed test, you have to divide the total alpha by 2. Okay. Because what happened is, you want to see if this is the average hour. Here is 22.3. Okay. Go back to your distribution. This is 0. So what you want is, you want a border that is smaller and larger. Okay. And because of that, alpha given to you is 10% significant level, so it's 0.1. Therefore, alpha divided by 2 is 0.05. Do you use t-test or z-test? Z-test. So you can write that n is more than 30. Therefore, you use z-test. Okay. Because you use z-test, then this is a z distribution. What is the critical region? That if here is 0.05, this is 0.05. You end up, correct. So it's 1.65 or minus 1.65. Okay. Then you calculate the Z statistic. You end up with what? Z statistics, you take 21.9, which is given, minus 22.3, divide by the standard deviation, which is given 5 minutes. Okay, because it's 5 hours, because it's square root of 25. It's giving you the variance. So again, I read your question properly. Do you give you standard deviation or do you give you variance? Divide by square root of 45. So this gives you approximately minus 0.537. Is minus 0.537 in the shaded or non-shaded region? Non-shaded, right? It's somewhere here. Minus 0.537. So it's actually, when it's in the non-shaded region, you accept null hypothesis. Okay? So the conclusion is you fail to reject your null hypothesis. You accept your null hypothesis. Okay, then you write your conclusion. Okay. Remember, it's only in the shaded region, then you reject the null hypothesis. Okay, at the very minimum, what we expect from all of you is that you do the calculations kind of mechanically. Okay, you may not understand all the concepts, but do the calculation mechanically. Now, I understand that statistics is actually not an easy thing to understand. When I'm your age, I have no idea what I'm calculating. I just read the question and calculate like a template. That is fine. The only time that I really learn about statistics is when I'm doing my PhD. And I learn how to explain it properly. So that's the third time I learn my statistics. Once I learned it in my poly days, no idea what is it talking about. But all I need to do is to do well for my exam. So I got B for that. When I was doing my undergraduate, we had to go through statistics class again. I have no idea what the lecturer is trying to say. He's a good lecturer, but he's an ecologist. So when he's talking about fish and all this, it doesn't make any sense to me. The only fish I care about is eating them. I mean, if he doesn't use concepts that I know like cells, percentage, all this, it doesn't make any sense to me, right? Like, what do they bother about how many fish he catch? And all this stuff. So yeah, the third time then kind of understand it. And you realize that statistics, don't try to learn statistics like 1 hour a week. It doesn't work as well. Statistics, if you can, after especially the whole of chapter 5, spend 1 whole day going through the whole thing again. Okay, that is because that comes the third time I learned statistics. I actually go for a specialized statistics course, which is 5 days. So it's Wednesday, Thursday, Friday, Monday, Tuesday. 9 hours per day. So it's within 5 days, you clear 45 hours. So every day you have statistics lecture. In the afternoon, you practice on it, doing your SPSS and all this. Then you keep on using it until you remember. So I went through 3 of that kind of courses. Yes, so don't be surprised. Okay. Okay, so question number 6. Okay. Okay, zookeeper in charge of the female panda. From experience, she eats an average of 12.3 kilograms of bamboo a day, and her eating habit is approximately normally distributed. However, after the news of the panda's pregnancy, the zookeeper thinks that there may be a change in the habit. So collect for a sample of 16 days. The mean is the mean is 11.9. Standard deviation is 2.1. Test at 5% significance. Okay, so let's see what is the null hypothesis. Yep. So null hypothesis is 12.3 kg. Alternate hypothesis?
Equal to 12.3.
What? No, not equals to, correct. Not equals to 12.3 kg. Okay, because it's not equal to 12.3 kg, it's a two-tailed test. Okay. Then you want the alpha divided by 2, in this case is 0.025, because alpha is 0.5. Okay, do you use t-test or z-test? T-test, right? You can say that n is less than 30 and population variance not known. Therefore, you use your t-test. Then you do everything. The t-value, you get 11.9 minus 12.3 divided by 2.1 divided over 6 square root of 16. Okay. Yeah, negative 0.762. Okay. But however, to make your life a lot easier, do an absolute. Okay, do an absolute, which then this gives you 0.762. Okay. Now, what is the critical value? T 0.025. Degrees of freedom here is 15. What is the critical value? 2.131. Correct. So, do you accept or reject null hypothesis? Accept or reject? Accept, right? Yeah, so you fail to reject null hypothesis means you accept null hypothesis. Okay, then remember your conclusion. It means that there is insufficient evidence to show the zookeeper's prediction is true. So it means that zookeeper's prediction is not true. Okay. What at the end of the day, when we are teaching stats, do you know what's the one thing that we are super frustrated about? Do you know what is the one mistake that we are very frustrated about? Anyone?
Rounding error.
No, rounding error is fine. Rounding error is still okay. The one that is we are very frustrated is when you have the statistic and the critical value, you give the wrong decision. Okay. When you have the critical value and the statistic, you give the wrong decision. That means you say that you reject null hypothesis here. Because when you have that, and sometimes some students will end up with that situation, we actually have no idea whether you know or not. Okay, every year we have a bunch of students that the test marks fluctuates a lot. It can be that one test somehow their brain managed to short circuit and managed to get through everything. They write the correct thing. But then that doesn't tell you that they know the stuff. Somehow they wake up that day. So the next time you do a test, in fact, the same paper can get it wrong. So this is the part whereby you have to get it right no matter what. And I stress this very strongly for one important reason. Okay. I have seen, I never tell this class, right? I have seen at least one student that get his entire master's degree failed because of this one statement. Write a wrong statement here. It is that serious. And how serious is it? It is the same level of seriousness that you say that, you know, you're writing something like solution of pH equals to 3.6. Therefore, the solution is a base. This is the level of error you have. Do you think when you mark this kind of chemistry exam, you're ever going to pass? No, right? Seriously, just that one error, you can fail the whole exam actually. Because your fundamental information is not there. Okay, so it's that serious, huh? So this is wrong. Please don't ever do that. Okay. Yeah. Okay. And don't be surprised don't be surprised some of the things that students can give us as well. I ever met a student more than 10 years ago. He sits right in the middle of the lecture room, insists that -15 is larger than -5. I'm like, how on earth, how do you even pass? How do you even get through your primary 6? Yeah. Okay. Again, this is, oops, dead wrong, please, huh? Okay. Okay, so, okay, question number 7. Okay, what time is it now? Am I out of time? Okay, still enough time. Okay, Let's say question number 7. Okay, my null hypothesis will be 73 purchases. And my alternate hypothesis, less than 73 purchases. Okay, so you're testing at 1% significance. That means alpha is 0.01. Again, please read the question. Okay, the significance level can be different. Okay. Then, do you use Z-test or T-test? Z-test, okay. Why do you use Z-test? Okay, so population variance or population standard deviation is known, therefore you use Z-test. Okay, so you calculate your Z statistic will be, the absolute Z statistics will be 1.46. Z critical, which is Z 0.01. Why is 0.01? 2.33. Based on this, do you accept or reject null hypothesis? Huh? Accept. Accept. Okay. Because even if both is there and minus, it's still accept. Okay. Otherwise, always draw it out. Okay. Here's 0. Here is what you have here is minus 2.33. Okay. Originally, your minus 1.46 is here. Correct? So it is still not within the rejection area. Okay. That is why I always do absolute, do the reverse. Makes your life a lot easier. So your sins is less than the Z critical, you fail to reject null hypothesis. Okay, and then you carry on. Okay. Question number 8. How about question number 8? So same thing here. Let's go to question number still 7 again. Because it is mirror image, we flip it over. Here is 2.33. We flip this over, it comes here. This is 1.46. So it's still in the non-rejection area. Okay, so question number 8. The average cost of 1 kg of rice last year is $3.47. From a sample of 15 suppliers, the mean is $3.56. Your standard deviation of 0.9 cents, 97 cents. Okay, is there enough evidence that the cost of rice has fallen? Okay, so the null hypothesis, again, is the original 3.74 per kg. Is it one tail or two tail? One tail, right? Because you're looking at whether is it fallen, and not whether is it increased. So less than 3.74 per kg. So it's one tail. Test at 1% significance, so alpha equals to 0.01. T-test or Z-test? Okay, because why? Your n is less than 30 and population standard deviation not known. So you use your t-test. Then your t, you end up with 5. Oh, my arm is going to break like that. Okay, 3.56 to absolute minus 3.74 divide by 0.97 over square root of 16. So you end up with about 0.742. While the critical region 0.01 or 15 is 2.602. So do you accept or reject null hypothesis? You know how to get 2.602, right? Okay, that should not be a problem, huh? Because if you do not know how to get 2.602, then the problem is rather big. So accept or reject? Accept, correct. Okay. So based on these two conclusions, since the absolute T value is less than the T critical, you fail to reject your null hypothesis. Okay, so the price, the conclusion is the price of rice has not fallen. Any of you over the last 1 or 2 weeks, you still go to food court and all this tapao food? Do you find that the serving is getting smaller? The amount of rice that they put in? Yeah. Okay. Yesterday I was having hor fun, and the last thing that I find is there is no prawn and then there's no fish inside. It's like, okay. What to do? Okay. So question number 9. Okay. So the null hypothesis is the average, the mean is 50. And you are testing whether it's a claim true or not. So it's a one tail or two tail? Two tail. So the alternate hypothesis is the mean is not equals to 50. Okay. Then the alpha is actually alpha divided by 2 is 0.025. The tested mean that you have is 59.7. That's from the 6 numbers. From how many numbers? From 10 numbers, n equals to 10. Okay. So this is from the values that's given. They calculated. Okay, so do you use the z-test or t-test? Z-test. Yes. Okay, so which means that you calculate the z statistic, you get about 3.01. Okay, the critical value 0.025 equals to 1.96. Conclusion? Accept or reject null hypothesis? Reject. Okay. Reject null hypothesis means you accept alternate hypothesis. Okay. So how you look at the way I write my statement, I will always write this way. Okay. Since my z value, my absolute z value, is more than my z critical value, okay, I reject my null hypothesis. Hence, I accept my null alternate hypothesis. Okay. Therefore, the mean is not equals to 50. Okay. Do you notice that I use punctuation differently here? Where do I put my comma? Where do I put my semicolon? Okay, this is a little bit of English. This is semicolon. This is comma. This is comma. Okay, please follow accordingly. Yeah. After the words like hence, therefore, hereinafter, thus, always comma. Okay, and these kind of words technically have to start in the beginning of a sentence. As much as you cannot start the sentence with the word because. You know, in secondary school, you're going to get it wrong. Same thing here. By right, you have to start hence, therefore, hereinafter, thus, at the beginning of a sentence. But in this case, if it's in the middle of a sentence, before these words, it's always semicolon. Don't use comma. Okay, the reason is, if you take the word hence, okay, after the word from hence onwards, this is a kind of complete sentence. Hence, accept now alternate hypothesis. That's a complete sentence. Since before the word hence is also a complete sentence, you can put a full stop. There's nothing wrong with it. If you join two complete sentences with a comma, that's called a comma splice error, which actually your secondary school teacher should teach you that. Okay. But I know a lot of secondary school teachers did not bother with that. Okay. Okay, so question 10. Okay, if the standard deviation of the number generated is not known, then do you use a t-test or z-test? Question 10 is actually based on question 9. The idea is, if the standard deviation of all the numbers generated is not known. Standard deviation of all the numbers is actually equivalent to the population standard deviation. So if the population standard deviation is not known, do you use t-test or z-test? Anyone at home? T-test or z-test?
T-test.
T-test, correct. Because you have two conditions. One is n is less than 30. And then now you have population standard deviation not known. So together, you use t-test. Okay, everything follows the same. The t critical value now, which is 0.025, degrees of freedom is 9. You get 2.262. Okay. But your t value okay, now you have, because your population variance is not known, you cannot use the population variance. You can only use the sample variance, which you actually calculated 59.7. Sample variance is actually about 25.02. So here we have 59.7 minus 50 divided by 25.02 over square root of 10. So you end up with about 1.23. So based on this, do you accept or reject null hypothesis? Critical, huh?
Is it reject?
Correct. No, how can you reject? The t statistic is less than critical. Okay, if you draw it out, this is the t value. The critical here is 2.262 and minus 2.262. So 1.23 is here. Remember this region, you accept null hypothesis. Okay. So I encourage you to draw out. Okay, so you can say that since is less than t critical, okay, you fail to reject null hypothesis. Okay, hence you accept null hypothesis. Therefore, the mean equals to 50. Okay. Yes, so that covers all the 10 questions. And then we look at the question 1 and question 2. So question 1. Okay. The answer is true, true, false, true, true. Okay, type 1 error is rejecting a true null hypothesis. That's correct. Type 1 error is actually the shaded region. The possibility of rejecting null hypothesis. Okay, if the null hypothesis is true. B is if two samples are drawn from very different population, yet they are so similar, and yet these samples are so similar that they cannot be identified as statistically significant, then we are committing a type 2 error. That's true. Okay, because they are technically different population. Okay, so it's opposite side. If everything remains the same, the hypothesis testing that significance at 5% significance will always be significant at 1%. May not be true. Okay, but the other way is true. If the hypothesis is significant at 1%, it will always be significant at 5%. Okay, think about the shaded region. If it's significant at 1%, means that it's less than 1%. When you look at 5%, it should be significant as well because it's still in the shaded region. So the opposite will not be true. Okay. Okay. What I'm trying to say is here. Let's say if this is the case, okay. So I have my rate. My rate here is 0.01. Okay. This beige is 0.05. If it's significant at 1%, that means it's here. It will be significant at 5%. If it's significant at 5%, maybe it can be here. It may not always be significant at 1%. Can be only. Okay. All right. If my p-value is less than alpha, it means that my test statistic is in the critical region. That's true as well. Okay. If a researcher wants to test the hypothesis that poly students weigh less than the average of Singaporean weight, a sample of 80 students weigh 65 kg and p-value is 0.03. It means that the mean weight of all the students is 65. There will be 3% chance. Yeah, correct. So that's true as well. 3% chance of the null hypothesis being correct. Okay, so question 2. Question 2A. Okay, Education Service claims that the average SAT score in 2012 is 610. Whether the mean score different from this claim. So the null hypothesis is the mean score is 610. The alternate hypothesis, is it one tail or two tail? Two tail, correct, because it's different. So let's look at B. A course manager suspects that the average age of year 1 student is 16.3 years old. Is he correct? So average is 16.3 years old. Alternate? One tail or two tail? Two tail, right? Because asking whether it's correct can be larger or smaller. 16.3 years old. Yes. Yeah, correct. So this is a hypothetical question. Just think about students as they say. Yeah. I know some of this question is the context is a bit weird. Okay. The course manager claims that the average year 1 student from VET is less than 16.5 years old. Okay. So in this case, now hypothesis is still 16.5 years old. What's the outer hypothesis? Small. One tail, two tail, one tail. But is it smaller or larger? Is younger. Correct. So the alternate hypothesis is it's younger, 16.3 years old. Okay. The average credit card bill is 3,200. A student feel that the average Singaporean is less than 5%. So he surveyed and found that survey 50 randomly selected Singaporeans and found the average is 3,500. So is the report correct? So based on hypothesis, the null hypothesis is the average debt is 3,500. So the alternate hypothesis, 3,200. So alternate hypothesis, is it one tail, two tail? One tail. More than or less than? Less than. Okay, so alternate hypothesis is less than 3,200. Yes. So that's it. Okay. Right, any questions? Okay. So again, if there's no questions, then that's all for today. Okay. Oops, what am I doing?
Thank you. Bye.
Yeah, bye-bye. Have fun. Make sure you all wake up for your test. What time is the test? Term test? 1. Okay, please wake up for term test, even though it's 1. Oh. Okay. Bye-bye. Have fun.